Similar occurs when you have the same shape but different sizes.
And that looks about half.
And they're in proportion to each other.
By half.
And congruent, right, is the same size?
Yeah, congruent is the same size, same shape. So congruent, similar is same shape, different size. Congruent is same size, same shape. So what we have is a situation where you have the exact same shape, but they're different sizes. Similar triangles, and so you know how I said they're in proportion? If I label this triangle, I'm going to make the small one ABC, and I'm going to make the large one DEF. If you have triangles that are truly similar, then the measure of angle A is going to be equal to the measure of angle D. The measure of angle E will be equal to the measure of angle B. And the measure of angle C will be equal to the measure of angle F. So angles are equal. Oh, sorry, let me put corresponding. Corresponding. So what that means is the angles that are in the same spot on the shape are going to be the same measure. Like if you were to take a protractor and measure them, they would be the same. So E and B are both 60, D and A are both 90, F and C are both 30.
Okay, I never really got that.
So that little m, if I hold on, I'm just going to come over here a second. If I write angle A like that, that just means the angle A.
Oh, so that thing is angle.
Yeah, this is angle. This is the symbol for angle. So this is just angle A. If I put a little m in front, this is the measure of angle A. So you can see why we do these little symbols so you don't have to write all that down. This will equal something. So maybe this equals, in our example, it equals 90 degrees. This doesn't actually equal anything. It's just talking about like angle A. It's a physical thing, right? Does that make sense? Okay. So like my cup that I just picked up, if this cup was called angle A, the cup itself is angle A, and the measure of angle A would be how much liquid is inside of it.
So you would say that as M is the measure of angle A?
Yeah. Yeah, exactly like that. Does that help now? Cool. And then it's the same thing with segments. Okay. If I, like, okay, when we have our triangle, right, and it was ABC, AB with no line over it means the segment AB. AB, sorry, with the line over it is the segment AB. AB with no line of it is the measure of AB. If you need it. So that's the length. And if I put an arrow, a double arrow over it, like this, it's a line AB, which means it doesn't end, so you can't measure it. And if I put a single arrow over it like that, it's the ray. No, it ends over here and it points forever in the other direction. So that's what those symbols mean. So if it has no line over it, it's talking about the length. So we're going to use that kind of a lot. And if it has a line over it, it's just talking about the actual physical segment right there. In this class, we're not going to use the ray and the line at all. That's going to be in geometry. Yeah, that's going to be in geometry. But we will be, that's why I circled this one. This is the one we will be using because we're going to be talking about length. Yeah, we're not so concerned about the physical line piece right here, whatever. We care about how long is it. Sides are in proportion. Okay, and so what that means is if I take this side AB and put it over the corresponding side DE, it will be equal to this side BC over EF, which will be equal to AC over DF. So the three sides, if you take the small over the large, will be equal to small over large, small over large. Corresponding sides in fractions together will be equal. Yeah, you'll want that. I actually did work out all these fractions. AB is 3 over DE is 6. BC is 6 over EF is 12. AC is 3 square root 3 over 6 square root 3. They all would equal 1/2 when I did the reduction. So if all of these are equal and they all equal the same thing, you're in proportion.
You add them up to 180?
Well, yes. We need to decide, okay, they need to either have, that's a 66. I'm sorry, it's not very clear. That was a 66. And these are both 57s. We need to have angles that are equal, corresponding angles being equal. So,
66 from 180 divided by 2.
yeah, 180 minus 66, because triangles have 180 degrees, right? So I'm going to do 180 minus 66, and I am going to get, let's see, 114. Now I need to know, there's two angles here that are the same measure. If they have the same number of loops on them, that means they're the same. So I'm going to take that 114, and I'm going to divide it, not equal, divide it by 2, and that's 57. So that makes both of these 57. Because there's two angles that are the same. So the whole triangle is 180, right? And I subtract this 66, and that gives me 114. But both of these angles together will equal that 114. Because the whole triangle is 180. Yes, triangles are always 180. So then I divide by 2, and I get 57 and 57, which is the same as these. And if both of these are 57, what does that make this one? Corresponding angles are the same. So the triangles are similar. Triangles is plural. Sorry, I'll make that plural. You guys are going to learn my geometry shortcuts now. Triangles are similar. Now the symbol for similar is a single curvy line. So I could say triangle XYZ is similar to triangle STQ. Yeah, I think so. It's called a tilde. But it's the symbol for similar.
Since they equal themselves, wouldn't they be
No,
congruent?
no, because they're two different sizes. Do you see that?
Yeah, but that's what I'm saying. They're two different sizes.
The angles are congruent, but the side lengths are not congruent. So the triangles are similar but not congruent. To be congruent, you have to have same shape and same size. Yeah. So, all right, we've got these triangles. We want to see if this triangle ABC is the same as triangle DEF, not similar. Triangle has an I in it. Okay, I had to fix that right now. Oh, well, never mind, I'll fix it later. Okay, so we want to determine if these two triangles are similar. So the best way to do it is to draw two triangles and label them. That's an ugly triangle. It was ugly. So I'm going to draw two triangles.
Nice.
I'm going to label them ABC, DEF. Now you always want to start in the same position and go in the same order as the triangles, the letters have been written. Okay, angle A is 68 degrees. and it says B and C are equal. Do you see that? So I'm going to mark that B and C are equal. So I'm going to give them each one loop. Okay, now we have over here E and F are equal. Oh, but they both equal 54. So I don't have to put this loop there. I can just write 54 there. It's cramped. Okay, so these are both 54. So I want to find out, are these triangles similar? So I can either use these two angles and figure out what this third angle is, or I can use this one angle and figure out what these two angles are. Which would you prefer?
The second one.
This one?
Yeah, because there's already two angles.
Okay, so I've already got two angles, so I want to find out what this third angle is, right? Well, the whole triangle is 180. And I have these two angles here together. So 54 times 2 is 108.
So no matter what
Triangles are always 180 degrees.
size they are, they're still 180.
Yep. If I drew a triangle the size of this room, it would still only have 180 degrees. Yeah. So 54 times 2 is 108. And then I take that 108 and subtract it from 180. And that gives me the missing side. Whoops, I wrote 180 twice. 108, which is 62 degrees. So this missing angle here is 62 degrees. Now, is there any way that these triangles... 72. Thank you. Good catch.
Somebody does your extra credit.
Yes, she does. Yes.
Extra credit.
So, 72, right? So if this is 72 degrees, is there any way that this and this are similar? No. So triangles are not similar. Well, because we'd have to have, this was 54 and 54 and 72. This is 68. 68 doesn't match any of those numbers.
So if the other one doesn't match any of those numbers.
Right. They have to all match, all three. It has to match all three.
Do you have a special sign for an accident? Like basically like
But it's not very good because, like, it kind of looks like a plus. So usually we just say not similar, or we say no. If the question says, are they similar? No.
I used to say that.
Here's what you do when you see a picture like this, where you've got a triangle inside of a triangle. Sometimes it's easier to deal with when you pull it apart and make it two triangles. So what I'm going to do is I'm going to draw, oops, that's not what I meant. This is what I meant. I'm going to draw two triangles because I have a triangle inside of a triangle. So I'm going to label the small triangle. So it's X, W, Y. And then the big triangle is X, V, Z. And these are both 90. And these are both X. So if one of them, it's the same corner, right? So I know that those two angles are the same, because it's the same corner. And then I'm going to label the lengths. This one is 4. See, there's 4. And this whole side here is 12. And this side is 5. And this whole side here is 15. And that's 9. And I forgot to put a 3 here. Sorry, can you guys write in a 3? That's supposed to be a 3. Now, if we want to determine, are these two triangles similar? We want to see if their sides are in proportion. Okay. So,
wait, if the small triangle inside the bigger one,
yeah, see this triangle inside that triangle?
they are proportionate.
Yes.
All the numbers match.
Right. So I'm going to do large over small, coordinating sides.
I like to wait for 2 seconds. I look back.
Okay. 9 over 3. 15 over 5. Are these all equal? Well, that's 3. This is 3. This is 3. So they are all equal. So yes, triangles are similar.
So they both have X's?
Yeah, 'cause see how this is one big triangle here? And there's a little triangle inside of it? And this corner is the same on both.
So when you see two triangles like that, do you have to always split it, or is it just like a good idea?
No, you don't have to split it. It's just if you split it, it's easier to look at. Like this is easier to figure out what you need to do than this. It's less confusing visually for a lot of people. You don't have to do it, but it sometimes helps. Now, is triangle ABC similar to triangle spelled wrong again? My goodness, I can't spell triangle apparently. Triangle JKL. Now, I can draw the triangles. So, there's two ways to do this. Okay, I'll show you the drawing the triangles, but first I want to show you something. If I have ABC and JKL, these go in the same order, so they correspond to each other. Okay, so whatever order, so I have AB is 6, right? Well, AB is going to go with JK. Do you see how they're in the same position? Well, JK is 3. So that's going to be 2. Does that make sense so far? So I took that AB and it goes with JK because they're in the same position. And then BC, which is 16. Why did I write B6? BC is 16. BC is in the same order as KL, so those two go together. So that's 8, which is also 2. And then finally, you have AC. AC goes with JL. Do you see that? Same positions? So you have AC over JL, which is 20 over 9, which is not 2.
So no.
So not similar. Okay, now that's if you don't want to draw the pictures. You just keep the letters in the correct order. If you want, you can draw the pictures and just label. Again, making sure that if you have ABC and you start here, you go ABC, then you do JKL, same order. AB is 6, BC is 16, AC is 20, JK is 3, 8, 9. So you can draw the pictures too. It's up to you whether if pictures work better for you, draw the pictures. If you can use this method and that works better for you, use that method. It doesn't matter to me which one you use. We have to decide which sides match. To do that, I'm going to look at the angles. 38, 38, right? And I go across, so 5 goes with 12.5.
The triangle on the left says 68, and on the right says 64.
No, it's supposed to be 68. Or no, it's supposed to be, this is supposed to be 60. They're supposed to be the same. I typoed it somewhere, or right-oed it. Yeah, it's supposed to be 60. So go ahead and fix that. That should be 60. Sorry. Okay, so do you see how that works? The ones across from the 38 go together. And then 82, 82.
Wait, is it 38?
Yeah, it's 38 and 60. 8 goes with C. Now what you want to do, I did small over large, right? Now it doesn't matter if you do large over small or small over large, but you must do it the same way on the second one. Okay? So if you did large over small, you'd have to do C over 8. Does that make sense? So that's the setup for the first missing value. Then I'm going to cross multiply. And I'm going to get 5c is equal to whatever 12.5 times 8 is. 100. And then I'm going to divide by 5. And c is going to equal 20. Yeah. Okay. And then I'm going to do the same thing to find this missing value, a. I'm going to go to green again. No, I'm going to do purple. Okay. These sides go together because they're both across from the 60. And I'm going to use the original 15 over 12.5, just in case I got this answer wrong. I don't want to use a wrong answer, so I always go back to the 2 original numbers I had, just to make sure. That way, if it's wrong, I only get half of it wrong, right?
You know what they need to do?
Uh-huh.
Come up with a pencil enough that you can change the color of, so you can do fancy stuff like that.
They should have a pencil that doesn't have 40.
Okay, so once I do the 12.5 times 7, I'm going to divide both sides by 5. And a is going to be... No, 17 point... That's not right. Oh, it is right. Okay. 17.5. No, we're finding the missing values, so it is equal. We're just looking for missing values. So our missing values were A and C. And so now we found them and we're done. So we're going to do the same thing here, but look, in this case, I'm missing an angle. Well, if these two angles are the same, then these two angles are going to be the same, right? So what's x equal? So we've got x. X was not too bad. X was easy. Now, I'm missing A. And A is across from 87, and 10 is across from 87. I have 50 is across from 8, and 50 is across from 24. And 43 is across from 7, and 43 is across from B. So that's the ones that correspond. Yeah. Where is on these triangles?
It's like how.
You figured it out.
Okay.
Why do you
Hold on, shh. I can't hear the question, guys. All right, you want to know why I'm circling them? Because you have to figure out a way to know which sides go with which sides. If you know the angles, the sides across from the angles, so 87 and 87, so that means these two sides go together because they're across from the same angle. No, it's not 10 because they're not the same size, right? They're in proportion. But that gives me a way to know which sides go together. Yeah. Not yet. Okay. Then I know that x I knew was 50 because these were the same. These were the same. So this had to be the same because the angles are the same, right? Angles are the same. Sides are in proportion.
So you just guessed that x is 50?
I didn't guess.
You know?
I know. Because if these two are 87 and 43, 87 and 43, these have to both be 50. Because it always adds up to 180. So it has to be the same. So that was that. And then this 50 is across from 8. This 50 is across from 24. So 8 and 24 go together. Okay. And then 43 goes across from B. 43 is across from 7. So B and 7 go together. That's just a way for me to figure out which sides match up. Does that make sense? At all? Because the sides have to match up. between the small and the large triangles.
And now you, I guess,
Well, what I'm going to do is I'm going to take the numbers I have. 8 and 24 are both numbers, right? So I'm going to...
so 7 and 10.
No, but 7 and 10 don't go together. 7 goes with B. Because they're in the same position. And 10 goes with A. So, but 8 and 24 are both numbers and they go together. So I'm going to put those together. So we're looking for the things that go together won't be in the same triangle. They'll be between the two triangles, but in the same position. Well, you have to start with both numbers so you can find the missing number. Yeah.
There's an easier way to do this kind of problem.
I know, but it doesn't always work. It doesn't always work because there's not always a whole number proportion between them. So what you did was divide or multiply?
I divided 24 by 8 and went 3 times.
Right,
So I multiplied
which will work in this example, but it won't always work because there's not always a whole number proportion between the triangles. So you're going to need to learn this method because sometimes your proportion is like 19.2738. And, or you know what I mean? It doesn't always work well. So I want you to know how to do this.
I think that would work though. It's still multiplication.
So let's do this though. I want you to know how to do this proportions because proportions come up in other parts of math too. So I did 8 over 24. So I'm going to do 7 over B. Because those will go together.
That's a B.
This is a B. It's a B. Remember, B's touch, 6's don't. Yeah. Okay. So cross multiply. And you get 8B is equal to 168. And then you'll divide by 8. I didn't write this high enough, sorry. And you'll get B is equal to 21. Okay, I'm going to cross multiply. And I'm going to get 8A is equal to 240. And I'm going to divide by 8. And I'm going to get A is equal to 30.
But you have 2 different answers.
I have an answer for B, and I have an answer. Yeah. You should have an answer for each missing letter or variable, or each missing value.
So B is 21 and A is 30.
And X is 50. Yeah, so you found your 3 missing ones.
But you didn't have to work that out.
No, it was just there. And we'll have a big long triangle with an X and an 11 and a little short triangle with a 5 and a 7. So X,
Other than this one, we're trying to find out if
we're just trying to find X.
And you know what you did before, you're splitting the triangles?
Uh-huh. So X over 5 equals 11 over 7. I just went from here to here and here to here. So 7X is equal to 55. This part okay, the splitting? Here's the big triangle, right? So that's X and 11. And then the little triangle was 5 and 7. No, ask questions. That's how you understand.
Since you did X,
So you could do it that way if you wanted, but not, you can't just combine them. So when you cross multiply and then you divide by 7, and you get 7.86 or something like that. We're going to have to round because it's not perfect.
so X equals 8.
No, we'll keep it a decimal. Yeah, because it's not going to be, it's not a perfect whole number ratio, so we're just going to keep it a decimal. This is how surveying works, by the way. You know how you see those guys with the tripods and they're measuring things and they're looking through stuff, and this is how surveying works, okay? So we're going to draw a picture. We've got Tori, We got Tori.
We went outside, we measured the shadow on one of the lights in the football field.
Cool. And Tori is 5 feet 6 inches. So I'm just going to write 5'6". Okay. And then Tori has a shadow. There's the Tori shadow. And that's 2'9".
You know what's sad? You know you can't draw nothing and try to draw something.
My stick figure looks like plankton?
No, not yours.
Oh.
Mine. I'm trying to draw like what you drew, and it looks, I don't know, it's horrible.
It's okay. You don't have to draw good. You just draw something. Okay. Now, she's standing next to a flagpole. Okay, flag. Woohoo! And the flagpole's shadow is 12 feet. And we want to know how tall is the flagpole.
It's a ratio.
It's a ratio because basically what happens
Make an extra crack now.
is it's kind of like similar triangles. Like this makes a triangle, right? So we can use the similar proportions. Now, here's the thing though. We have to have all units the same. So I can't have this foot inches thing. So I have to have everything in feet or everything in inches. Feet? Okay, so 5 feet 6 inches is 5.5 feet, right? That one's relatively simple. 2 feet 9 inch. Feet has a T. 9 inches. Okay, now this one I'm going to have to figure out. And to do that, I'm going to divide 9 by 12 to get my decimal part. 0.75, so that's 2.75 feet. Okay, so now we're in all feet and we're good. So the 2.75 and the 12 go together because they're both the ground, the shadows. And then the 5 goes with the flagpole, which I'm going to call X. Or actually, what letter would you guys like to use for the flagpole?
Q.
Q. Okay, we're going to call it Q. Why Q? Just because?
Yeah.
Alrighty.
Could you take capital Q though?
Yes, it can. I'll change that. Be any letter you want. Q. Good?
Yeah.
Okay. Cross multiply. And I get 2.75 Q is equal to 12 times 5.5, which is 66. Divide both by 2.75. And Q is 24 feet. That's the flagpole, so 24 feet tall. And that's how they figure out like how tall trees are and you know how far away things are and stuff is by like these proportions, like triangular proportions.
But 2 feet 9 inches isn't half 5 feet 6 inches.
Well, okay, you guys agree with me that 5'6" is 5.5, right?
Yeah.
It's half. It just doesn't seem right, but it is.
So,
Triangular geometry, and more specifically, geometry is the study of the relationships between has 2 E's in it. Okay, so and it's a relationship between the angles and the lengths of the sides. of these triangles. Okay, so we use trigonometry in right triangles. So this is a right triangle. A right triangle is a triangle with a 90-degree angle. Okay, and a trigonometric ratio is it compares the two sides. Of a triangle. Okay. And we're talking about right triangles again. We're always talking about right triangles on these. Okay. Now, excuse me. The three main trigonometric, can't speak today. The main three are sine, cosine, and tangent. Okay. And you'll remember from our talks of Pythagoras, we have A, B, and C, which is the hypotenuse. Don't like my B. Okay. If I call these angles A, B, and C, and I want to find measures in relationship to angle A, okay? The sine of angle A, we call it sine A, okay? And that's going to be the leg opposite angle A over the hypotenuse. Yeah, leg, sorry. Okay, well the leg opposite A is little a. So the sine of A is going to be A over C. Okay. The cosine of A is symbolized cos A, and it's going to be the leg adjacent. I can't spell adjacent. A-C-E-N-T to angle A over the hypotenuse. Well, the leg adjacent to A is right here. So this is opposite, and this is adjacent. So this is going to be B over C. And then the tangent, which we call tan A, is opposite over the leg adjacent. So in that case, it's going to be A over B. Now there are a couple ways to think or to remember these sine, cosine, tangent. You could also write it as opposite over hypotenuse, adjacent over hypotenuse, and then opposite over adjacent, where O is opposite, A is adjacent, and H is hypotenuse. Yeah, and I wrote hypotenuse, thank you.
I don't understand how you getting numbers.
Where am I getting these?
Yeah, like AC, DC, AD. I don't understand.
See this picture? I'm looking for the leg opposite A. Here's A. That's the leg opposite.
So how did you get C?
C is the hypotenuse. Got it? Is that better now? Okay. And then the other way you can think of them is like this, where you use opposite hypotenuse, opposite adjacent. So this A is not the same as that A. That's why I'm circling it a little bit in red. So these are using those symbols. And there's two ways to remember this as well. Did I put space in there? No, I didn't. Darn it. Hold on one second. In your packet, do you guys have? So sine, cosine, tangent. How do we remember this? Two ways. You can either take a trip to Camp Sokotoa, sine, opposite over hypotenuse. Cosine, adjacent over hypotenuse. Tangent, opposite over adjacent. So Camp Sokotoa. Does that make sense? So that's one way to remember which one is which. The other thing is a sentence. Oscar had a heap of apples. This one I don't think is as useful, but you have opposite over hypotenuse, and you have to remember that sine is first. Then you have adjacent over hypotenuse, not Hebe. I'm going to write Hebe. What's a Hebe?
Sounds Middle Eastern.
You have adjacent over hypotenuse, and you have to remember that that's cosine. And then you have of apples, so that's opposite over adjacent is tangent.
Can I do that real quick?
Yeah, of course. So I personally think Camp Sokotoa works a little better because it gives you the sine, cosine, and tangent in there. But if it's easier for you to remember Oscar had a heap of apples, like either one of these will work. And if you have another method that you can come up with, that works too. We're combining things. First, we need to find out what this is. And how can we find this out? It's a right triangle, so we're going to use our good friend, the Pythagorean theorem. So if I make this A and this C, I have 9 squared plus B squared is equal to 15 squared. 81 plus B squared is equal to 225. Subtract 81 from both sides, and then come upstairs. And I get B squared is equal to, I don't feel like doing this, 144. And if I take the square root of both sides, B is equal to 12. So 12. All right, so now we have all three sides. We have to have all three sides to be able to find the sine, cosine, and tangent ratios. So do you guys like Sokotoa? So Sokotoa, right?
What's Sokotoa?
That's what I just did here, Sokotoa.
She's going back, y'all.
So Sokotoa, sine is opposite over hypotenuse. So the sine of A is opposite over hypotenuse. So opposite of A is 9. And hypotenuse is 15. Now I need to reduce that.
What do you write?
Sine. That's what you have to write. The sine of A is equal to opposite. So I'm going to reduce this, and it's 3/5. So the sine of A is 3/5. The cosine of A is adjacent over hypotenuse, because we're at the ka part. A 9 is opposite, 12 is adjacent. So it's going to be 12 over 15. And I need to reduce that. They both divide by 3, so it's 4/5. And then we have the tangent of A, which is opposite over adjacent. Opposite is 9. Adjacent is 12. They both divide by 3, so we get 3/4. And the reason I have to do this sine A, cosine, like so it's sine A, cosine A, tangent A, is so I know which one I'm talking about. Not just which ratio, but also which angle. Because then I can go and find them for angle B now. Just do the same thing, except for angle B, the sine of B is going to be opposite over hypotenuse. Well, 9 was opposite of A, but 12 is opposite B. Do you see that? So it's going to be 12 over 15, which is going to be 4/5. So the sine of B and the cosine of A are the same. And then if I do the cosine of B, that's adjacent over hypotenuse. So that's 9 over 15. So that's 3/5. So the cosine of B is the same as the sine of A. And then the tangent of B is going to be opposite over adjacent. So that's going to be 12 over 9. So 4/3. Sine is the ratio of the opposite side of a triangle over the hypotenuse.
What does that mean?
It means it's the ratio of the opposite side. It's a relationship between angles and the lengths of the sides of the triangles that the Greeks determined. So this angle A has this opposite side and this hypotenuse and then this adjacent side in this particular triangle. And so the angle A has a relationship using something called sine of 9 over 15 with these two sides. The Greeks figured out that it doesn't matter what size your triangle is, that if there's like a 40-degree angle and you have these different sized right triangles, the ratio between if you're talking about sine,
Oh, I see.
the ratio between the opposite and the hypotenuse will always end up being, it's not 3/5 because that's not a 40-degree angle, but if it was 3/5, it wouldn't matter what size your triangle was, a 40-degree angle is always going to have that ratio be 3/5.
Oh, that's the angle of A?
Yeah. And so that's what they figured out, that it doesn't matter how big or small the triangle is. And so then now if you know the ratio, you can figure out angles. So you can go backwards and forwards. That was the whole point of it.
Right.
Yeah. I can find out the length, or sorry, the measure of angle A because the triangle is 180 degrees, right? And this is 90, and that's 41, so I just have to find this missing one. So angle A is going to be 180 minus 90 plus 41. So that's going to be 180 minus 131. So that's 49 degrees. Did I do it? Yeah, 49. Okay. Now I can use my trig ratios to find the missing sides. Okay, I only have one side here. So I have, if I use angle, do you want to use angle A or angle B to find these?
B.
Okay, so I'm going to use angle B. This is opposite, this is adjacent, correct? So opposite over adjacent is tangent. Oops, I meant to write. Okay, so tangent of angle B is equal to opposite over adjacent. So I'm going to use tangent of 41 is 6 over A. But I don't know what that is. But there's this thing in math that tells me if I'm dividing by a variable, and I have some number over here, I can switch them.
Really?
Yeah, here's how it works. I multiply both sides by A to get the A out of the denominator. So I get A tangent 41 is equal to 6. And then to get the A alone, I divide by the tangent of 41. So I get A equals 6 times the tangent of, or sorry, divided by the tangent of 41. So I could have just switched those because that's what happened. So now you're going to go to your handy dandy chart.
Don't do that.
Remember how I gave you a chart?
There's a chart.
There's a trig chart. I don't remember which one I gave you guys. I think I gave you this one.
There's no place here.
I gave you this one, right? 41. Where's 41? Why is that 45? Oh, here's 41. Okay. It goes sine, cosine, tangent. The tangent of 41 is this number right here, 0.86929. See that? So I'm going to plug that in. So that is equal to 6 divided by 0.86929. So,
That's why it's not cute, right?
Huh?
Oh,
so A is 6.9.